Here I'll show you how to compute STAs for your experiment. So it's pretty simple. You can use the function called compute STA. So you go into MATLAB and you can directly use the function, for example, in your command window. So I'll just run it on my experiment called test here. Like this. So before you launch it, remember that the STAs are computed on the checkerboard, on the responses to the checkerboard. So if you have more than one checkerboard sections, you will be asked by the program to choose which one you want to compute the STAs on. Also, before computing the STAs, you might want to make sure that the parameters that you have on the checkerboard configuration file are correct. So, is the frame rate correct? Are the settings that you chose for the checkerboard correct, in particular the size of the checkerboard? So once you know this is correct, you can actually launch the function. And this will first generate some parameter files, and then it will just run for a few minutes. So once the computation is finished, you can open again the experiment folder, and you'll see that you can find inside the process folder the variable called STA, which is both the three-dimensional spike trigger average for each of your cells and the temporal and spatial the factorized components of it. You can, if you want, plot these components using the plot experiment STA function. First you write the name of the experiment and then the index of the cell that you want to use, that you want to plot. So right now, for example, I'll show the first cell, and you get a plot that looks like this. So on the left you have the temporal component, and on the right the spatial one, with an ellipse fitting the spatial component, which represent the receptive field center of the cell. Clearly, depending on on your cells, there will be some cells which have a very noisy STA where you cannot really find good defactorization, so you cannot get temporal and spatial components, and in that case, as shown here, you will get a warning for that if you try to plot the components of a cell that could not be defactorized.